and I will get 2 log 5x equals 12. Then I would do what? Divide by 2. Bless you. Log 5x equals 6. Now, since that log is isolated, I'm dealing with one log. Could I write it in exponential now? Yes. What's your understood base there? 10. So 10 to the 6 equals 5x. So what's 10 to the 6? Check it. Make sure. Yep. It's 1 million divided by 5. What do you get? There's your answer. 200,000. Guys, these equations are so important. Third and weeks we do these equations every single day in Math Workshop to keep you fresh on them. Yes, hon? Yes, you do want to get rid of the 2, yeah. She was talking about bringing it back up as power to power. No, just go on divide by 2. Number 4, is your log part isolated by itself? Yes, so you're ready. Okay, it's in logarithmic. I'm going to put it in what? What form? Exponential, because that's the inverse of logarithmic. What's your understood base here? So I'm going to do e to the first equal 2 plus x. Guys, I would simply type in my calculator e to the first. Second, e to the first. And then subtract what off of it? Yep, and round. X equals 0.718. I remember doing these last year. Yes. Last year's intro, this year you got to get really good at it. Number 5, I mean. Is your log part completely by itself at the moment? No, so what you need to divide both sides by? That's what I would do first. You want to get your log part by itself. So natural log of x equals 8. Now, let's put it on exponential. It would be e to the what? Equals x. Well, that's all you got to do is type in your calculator. So, x equals 2,980.958. Guys, we're not skipping receipts for time's sake right now, but we'll just discuss how we would solve that. Yes, Ivy. Okay. You see that, huh? Are you sure? You don't see that you typed in negative 8?
No, I see that. But oh, because it's negative divided by.
Okay, on this one, what would be the first thing you do? Move the what over? Divide by, and then put it in exponential. Are you sure? All right, number 7's typed wrong. Where that first set of equals should be a plus, okay? That should be a plus. Okay, let's talk about this. This is why we learn properties here. Do you just have one single log in that problem? No. You have more than one. You have a log that's the same base. They both base what? Both logs are base what? 10. I'm never going to give you one that has two different bases. You're not going to have that.
It would be no solution if it was with a different problem.
It just be complicated, but you're never going to see that. So you want to get down to one log. Okay, this is addition. What rule do you think we're going to use with this? Product. So you're going to rewrite this as log x plus 2 times x minus 1 equals 1. What do you think we're going to do right here? FOIL it out. X squared, that's going to give you minus x plus 2x minus 2. So I multiplied x plus 2 times x minus 1 and got x squared plus x minus 2. Yes. Yes. Now, do I have one single log? So now I'm going to write, what's the understood base there? 10 to the equals. So I'm at 10 to the first, which is 10. And now what type of function am I dealing with now? So I got to set equal to 0. We would factor every day, every month in here, so you can never forget how to factor. It's got to multiply to give me negative 12, add to give me 1. What 2 would do that? Plus 4 and negative 3, won't it? So you're going to set both of them equal to 0. And here I get negative 4. And here I get 3. Now, when you get more than one answer, and when you transform from a logarithmic to a quadratic, do you need to see if both your answers can be put in that problem? Yes. Okay, the main thing about logarithmic is you cannot have a negative number sitting next to a log because what? Logarithms are not defined for what? Negative numbers. So if I put negative 4, what's negative 4 plus 2? Is negative 2 sitting next to log? Yes, so that cannot be your answer. You cannot have a negative value sitting next to a log. Plug 3 in. 3 plus 2 gives me 5. That's fine. 3 minus 1 gives me 2. Is that okay? Yes. You said, Mr. Fisher, what if both of them does not work? Then it's no solution. But here your only answer is 3. Okay? Now, I want you to notice something between 7 and 10. I want you to look at the structures of those problems for just a second. All right. What do you notice in number 10 that's not in number 7? There's here you have log base 4 throughout the problem, don't you? Here you didn't have that log there. So this is in fact an easier problem than that, okay? If you have the log base, the same log throughout the problem, you can just ignore it and solve it. You said, Mr. Trish, what you talking about? If you have the log with the same base throughout it, now you still do the properties, but this is what you do. What's addition is right here. So that's product. I just multiply 3 times x minus 2. So I get x equals 3x minus 6. X equals 3. And that's all you do on that problem. So that's why I want you to notice the difference between the structure. Here you don't have that log base. You still have to, when you get to this point, have to write 10 to the first equals that. But when you have the log base, you can just temporarily ignore those. You still have to apply the property, because this is product, multiply, but you don't have to worry about the log base 4. Does that make sense, the difference? Okay. Let's look at number 8. If I look at this structure, can I just temporarily ignore the log base 10 here? No, because it's not found throughout the problem, is it? So I still have to apply my properties because I got more than one log on it. So this is addition. So I'm going to write it as log x times x minus 3 equals 1. Now, I'm down to 1 log. Can I write this in exponential? Can I write that in exponential? So it would be what? 10 to the first equals x squared minus 3x. 10 equals x squared minus 3x. I'm going to get that equal to 0. It's got to multiply to give me negative 10, add to give me negative 3. That's negative 5 and positive 2. So I get x equals 5 and x equals negative 2. Which one cannot work? So your only answer is 5.
Bueno, that's all.
Now let's look at number 11. The first thing you ask yourself on a logarithm, do you have just one single log in there? Look at me. Do we just have one single log on number 11? We have 3 logs in that problem. We have that log there, there, there. Now, yes, they all have the same base, but we have 3 logs. So can I, if you have just one, then you can put it in exponential, can't you? But I have 3, so I'm going to have to use my second strategy of applying some properties. Now look at the structure of number 11. What do you notice? They all have what? Log base 5. So can I ignore that? Yes. What's this plus tell me? What rule am I going to do? Product rule. And I'm down to that. Now that's going to give me x squared plus x minus 20 equals 0. I got a factor. That's going to be x plus 5, x minus 4 equals 0. So I get x equals negative 5, x equals 4. Which one can I not plug in there? So what's your answer? 4. One more. First thing you ask yourself on log, do I have one single log? No. So can I do toolkit strategy 1 and put it in exponential? No. Second, you got to use some properties. What property do you see in there? Quotient, don't you? Because subtraction. So I'm going to rewrite this. Can I just temporarily do away the log base 7? No, because not all of them has that. So you guys can keep it right now. So log base 7 of x minus 6 over x plus 5 equals 1. I put that in the numerator because it comes first. Now, I'm ready to write an exponential because I got one log. 7 to what power? How do you think we handled this right here? Just cross what? You just cross multiply. 7 times x plus 5 equals x minus 6. So I get 7x plus 35 equals x minus 6. 6x plus 35 equals negative 6. 6x equals negative 41. Divide by 6. X equals negative 41 over 6. Now let's make sure when I plug that back in, that gives me a negative number right there. When I plug this back in right here, you always have to check to make sure here. If I plug that back, because that caught my attention right here, negative 41 over 6. If I plug that in right there, that would make it a what right there? So what would be my answer? No solution. You don't see that much. Usually you just got to check them with 2, but yeah, that would be no solution. Alright. So over the last 2 days, yes, Tyler?
On those, do you want us to write the answers as fractions or the actual repeating decimals?
Either way, I'm good with. So what we've done the last 2 days is yesterday we learned exponential. Today we learned logarithmic. Tomorrow you're just practicing. You're not learning anything new. We're just going to be. I'm going to throw you an equation, and you got to tell me what would you do in this situation. We're going to do that tomorrow and Thursday. Just practice, practice, practice. Monday, same thing. Practice, practice, practice. Your homework is 65 through 72 on that same page. 8 problems. Yeah, 8 problems.